Hi, 7th graders. Today we're going to go through lesson 7 called Will It Fit? So if you would like to follow along on Desmos, you definitely can. It won't be 100% the same as what this one is because this is technically a paper lesson, but most of it should be the same. So if you want to follow along, you can, and then split your screen and follow along with what I do and write that down. That would work. Or if you just want to watch the video, you can do that as well. And then after the video, you can work on the assignment. All right, so activity 1. Karima creates a scale drawing of the basketball court she wants to build in the local community park. The park's board of directors approved building the court in a 20 by 20 meter area of the park. Will her vision for the basketball court fit in the designated area? So I just want you to take a second and do you think this would fit in a 20 by 20 meter area? Alrighty, let's move on. So here's a scale drawing that Karima presented to her neighborhood's park board of directors. The scale for Karima's drawing is 2 centimeters to 5 meters. We need to explain what this means in real life, or in our own words. Well, we had 2 centimeters to 5 meters. That's our scale. This 2 centimeters is talking about our drawing. So this is talking about the scale. Whereas the 5 meters is actually talking about real life. So what it would actually be in real life. So this is the actual length, or I'm going to write real life too. All right, so that's what our scale means. So that 2 centimeters is how big it is in the drawing. The 5 meters is how big it is in real life. So now let's take a look at number 2. It says, will Karima's court fit in the 20 by 20 meter square area the park directors designated for the court? Use your measuring tools and the table below to help you with your thinking. Round each measurement to the nearest tenth of a centimeter. All right, we're not going to actually measure what each of these distances is. I will just write those in. So our length was 11.2 centimeters if we actually measured it. 6 centimeters for our width. Our hoop to 3-point line was 2.8 centimeters. And then our 3-point line to the sideline was 0.4 centimeters. All right, so now we need to figure out how big it is in real life or in our actual court. So to do this, we set up our butterfly. Whoops. We are talking about meters and centimeters. If we take a look at our scale, it was 2 centimeters to 5 meters. So 2 centimeters would go down here. 5 meters would go on top. And then we look at our length of the court. That was 11.2 centimeters. So that is the bottom. X would go on top. We do our butterfly. 5 times 11.2 is 56. 2 times x is 2x. We divide by 2, divide by 2. 56 divided by 2 gives us 28, and we're talking meters. So that is our answer for the first one. Okay, now we do the same thing with the width. So we are, again, still doing our butterfly. We're talking meters and centimeters. Our scale is still the same, so that 2 centimeters to the 5 meters. And then this time our width is 6 centimeters. All right, 5 times 6 equals 30. 2 times x equals 2x. We divide by 2, divide by 2. X equals 15 meters. And that is the length, or our width of the actual court. Okay, moving on to our hoop to the 3-point line. It's 2.8 centimeters. We're going to do our butterfly again. We're still talking centimeters and meters. It was 2 centimeters to 5 meters. And then we had 2.8 centimeters. X on the bottom. 5 times 2.8. I don't know what that is off the top of my head. We get 14. 2 times x equals 2x. We divide by 2. And I get x equals 7 meters. So that is our answer for the hoop to the 3-point line. And then lastly, we have our 3-point line to the sideline. Again, we're doing centimeters and meters. Our scale was 2 centimeters to 5 meters. And now this time it's 0.4 centimeters. 5 times 0.4 gives us 2. 2 times x equals 2x. We divide by 2. X equals 2 divided by 2 is 1 meter. And that is our answer for our 3-point line to the sideline. So now we need to answer our question, will it fit or not? So if we take a look up again at our picture, our length we said was 28. So that means from here to here, that's 28 meters. And then if we look at our width we said was 15 meters. So our whole court, or our whole park, is 20 by 20. Our width would definitely fit because that's below 20. But our length is much bigger than 20, so that one would not fit. So it does not fit. All right, moving on to activity 2 called Fix It. It is asking us, how would you recommend Karima adjust her proposal so that it fits? Well, we could make all of our sizes smaller. So we could adjust our scale factor. Or another thing that we could do is we could just make a half-court basketball court. Or if you have another idea, that would work as well. But we cannot keep it how it is because it will not fit. All right, so then in our second one, it says, sketch your proposed court for the 20 by 20 meter park area. Label your sketch with all the necessary distances. So for this one, we're just gonna do a very brief sketch. Okay, so let's pretend that we're just gonna adjust our scale factor. So instead of it being this 28 meters long, what if we adjusted it and we multiplied it by a smaller number? Well, what if we do, let's see. What if we adjust our scale factor to be 0.7? That's smaller than what we have now, so our numbers should get smaller. So to do that, I'm just going to draw my little rectangle here. This is my length, and this is my width. So what we need to do is we need to go back up to our top, and we said that our length was 28. I need to take 28 times that 0.7. When we do that, we get 19.6 for our length. That would fit because remember, it has to be under 20. Okay, now let's do the same thing with our width. Our width was 15. So again, we're going to take our 15 times 0.7. And we get 10.5. So 10.5 meters would be our width, and that would also fit. So that's just one example of something that we could do to get a smaller basketball court. If you chose another way, that would work as well. All right, it says the basketball court will share the 20 by 20 meter park area with an outdoor seating area. After the court is built, how much area will remain for outdoor seating? So that depends on the one that you picked. We're going to skip this question depending on if you tried something different. And we're also going to skip our lesson synthesis and jump right to the cool down. All right, our cool down says a scale drawing of a school bus has a scale of 1 inch to 5 feet. If the length of the school bus is 4 inches on the scale drawing, what is the actual length of the bus? All right, so we need to set up our butterfly. In this problem, we are talking inches and we are talking feet. The first thing that we need to do is put in our scale. So half an inch is 0.5. 5 feet would go underneath it. And then our school bus is 4 inches on the mat, or on our drawing, so that would go on the top. X on the bottom, we do our butterfly. 5 times 4 is 20. 0.5 times x is 0.5x. We need to get rid of the 0.5, so we divide. So we need to take 20 divided by 0.5, and we get 40. And we are talking about feet. Alrighty, that was our lesson on 1.7. I hope it made sense. What I would like you to do now is work on the yuck. If you finish it before the bell rings, go ahead and do 1 stack of cards on fact fluency. Then you can do prodigy, read, draw, or the done folder. Send me a message if you have questions. Otherwise, have a great rest of your day. Bye.